So, hello again guys, it's me again, Frederick Atigbak. So, good evening. Good evening guys. So, for now, I create a summary of a chapter 8 titled IP Network. Subnet IP Network. So, let's go. So, let me start. So, chapter 8 Subnetting IP Networks. So, chapter 8 section and objectives. So, 8.1 Subnetting an IPv4 network. So, implement an IPv4 addressing schema scheme to enable end-to-end connectivity in a small to medium-sized business network. So it's gonna explain how subnetting segments to a network to enable better communication. Explain how to calculate IPv4 subnet for a 24 prefix. Explain how to calculate IPv4 subnets for a 16 and 8 prefix given a set requirements for subnetting. So, implementing an IPv4 addressing scheme. Explain how to create a flexible addressing scheme using variable length subnet masking or BLSM. 8.2 Addressing schemas. So, given a set of requirements, implement a BLSM addressing scheme to provide connectivity to end user in a small to medium-sized network. Implement a BLSM addressing scheme. So, 8.3 Address schemas. Explain the design consideration for implementing IPv4 in a business network. So, explain how to implement IPv6 address assignments in a business network. So, IPv4 subnetting an IPv4 network. So, first the broadcast domain. So, device is used broadcast in an Ethernet LAN to locate. So, other devices address resolution protocol or ARP. So, which sends layer to broadcast to a known IPv4 address on the local network to discover the associated MAC address. So for the services, dynamic host configuration protocol or what we call DHCP, which sends broadcast on the local network to locate a DHCP server. So it switches propagate broadcast out all interfaces except in the interface on which it was received. So there's a picture. So there's an internet and the broadcast domain. So network segmentations problems with large broadcast domains. So hosts can generate excessive broadcast and negatively affect the network. So slow network operation with a significant amount of the traffic it can cause. So slow device operation because of a device must accept and process each broadcast packet. So solution, reduce the size of the network to create smaller broadcast domain. So these smaller network spaces are called subnet. So there's two pictures in the end of it. So first is the one broadcast domain and next the broadcast in LAN 1 contain in one subnet. Then the last is broadcast in LAN 2 contain in one subnet. So reason for subnetting: reduce overall network traffic and improves network performance. It enables an administrator to implement security policies such as which subnets are allowed or not allowed to communicate together. So there's a lot of pictures. So there's subnetting by location, communicating between networks, and subnetting by device. So it is the octet boundaries. So network are most easily subnetted at the octet boundary of 8, 16, and 24. So the prefix length and the subnet mask are different ways or identifying the network portion of an address. So the subnets are created by borrowing host bits of network bits. So more host bits borrowed, the more subnets can be defined. So subnetting on the octet boundary. So the subnetting network, so 10 times to 0 and 16. So define up to 256 subnet, which subnet capable of connecting 65,534 hosts. So first, the two octets identify the network portion, while the last two octets are the host IP addresses. So subnetting on the octet boundary. So subnetting network 10xx0/4. So define the 65,536 subnets, each capable of connecting to 54 hosts. So 24 boundary is very popular in subnetting because of the number of hosts. Subnet. So it's all a video. So creating a for subnet. So there's a many topology for subnetting for this. So calculating the host. So there's two pictures. So I mirrored in the end. So 2 and 9 equals 512 IP addresses per subnet. So 2 and 9 minus 2 equals 510 host IP address per subnet. So address the range for 172.16.0.00/23 subnet. So in creating 1000 subnet with a over 8 network. So borrowing 1 bit, borrowing 2 bits, borrowing 3 bits, borrowing 4 bits, borrowing 5 bits, borrowing 6 bits, borrowing 7 bits, borrowing 8 bits, borrowing 9 bits, and the last borrowing 10 bits. Creating a 1000 subnets with a over 8 network count. So subnetting based on host requirements. So subnetting based on network requirements. So host devices used by employees in engineering department in one network and management in a separate network. So there's a human resources, sales, executive management, research and development, engineers, and technical support. And it's all over scope of the corporate network. So topology, packet tracer, variable length subnet mask. So there's a two picture, traditional subnet and subnet of varying size. So that's all for now for this summary. So please don't forget to subscribe. Thank you.